Hey everybody, we are continuing the pre-cal 6.2 unit circle part. So here we have sine of 60. So think about the ordered pair for 60 was 1/2 comma square root of 3 over 2 x, y, cosine, sine. We want the sine, so that's square root of 3 over 2. And cosine 45, it has square root of 2 over 2 for both of them. And so that's the one you want. They just want a common denominator. Now don't turn that into square root of 5, because think of the square root kind of like an x. They're not like terms. So you could have thought square root of 3 plus 2 square root of 3 is 3 square root of 3. But you can't say square root of 3 plus square root of 2 is square root of 5, because that's false. Okay. On this one, we're doing the exact answer, which means you can't just use your calculator. Although you can see in this case, it turned out to be a whole number. But the point is, you're told cosecant 30, and that's 1 over sine 30. And we know our 30 degrees was square root of 3 over 2, comma half. So sine would have been 1/2, cosecant would have been 2. Then 45 degrees would have been square root of 2 over 2 for both of these. And if it's tan, it'd be y over x. And if it's the same thing, it's just 1. So we get 2 times 1 is 2. Now, if you are using a calculator, make sure you're in degree mode by clicking that, or just use your degree symbol, like hit the pi button, and then here's the degree symbol. Cosecant 30 times tan 45 degrees. Whoops, I did pi. And so I get 2. So that's your answer. Now, on this one, we use 90 degrees. And so your ordered pair for 90 is 0, 1. And we want the sine of 90, so that's just 1. So in our expression, we have 9 times 1. Now this other part is minus 2 cosine 180. So at 180, we have ordered pair negative 1, 0. And so the cosine would be negative 1. And in your formula, we have minus 2 times negative 1. So that turns into 9 plus 2, which is 11. So that's your answer. Now on this one, again, they don't want the calculator. Well, the other two, you got a whole number, and so it worked. Here, you really can't. You have to use your unit circle. Use your unit circle. Remember that pi over 4 is equivalent to 45 degrees because it's like 180 over 4. And we want pi over 4 as square root of 2 over 2 for both x and y, because we're just talking about this one with square root of 2 over 2. And cosine, the cosine answer is this. Now, to get the secant, it's 1 over cosine, and so think of it as 2 over square root of 2, and then rationalize it. You get 2 square root of 2 over 2, which is just square root of 2. So you could do it that way, or think the original square root of 2 over 2 is 1 over square root of 2, and then flip that and turn it to that. So that's how you get that part. So 4 times secant of pi fourths means 4 square root of 2. Now the next part is the plus 7 cotangent of pi fourths. Well, the cotangent of pi fourths, the tangent would be 1, and so would the cotangent, because the tangent would be y over x, and the cotangent would be x over y. So this is just plus 7 times 1. Now these are not like terms. You cannot change it to 11 square root of 2. Just think of it as separate, not like terms. So that's your answer. Now on 210 degrees, that type problem, look on your unit circle first to see if you already have everything, and you do. So on 210, I'd write down my ordered pair, negative square root of 3 over 2, comma, negative a half. And this is your cosine, this is your sine. So the sine is the y, so you just type that in. Cosine is your x. For the tangent, you're doing sine over cosine. So negative 1/2 over negative square root of 3 over 2. Your negatives cancel, and so it turns to positive. And your 2's cancel, so you get 1 over square root of 3, which is equivalent to what they want. Remember, they want to rationalize it, so it's square root of 3 over 3. So that's how you do that. So for this one, for cosecant, it's 1 over sine. And so you basically flip negative 1/2, and there you go. And on this one, you want to flip negative square root of 3 over 2. So you get negative 2 over square root of 3, which then turns into negative 2 square root of 3 over 3. I didn't show my parentheses times, but that's what it turns into. And then on cotangent, we start with 1 over square root of 3, and that gives you it. Or flip square root of 3 over 3, which takes a little bit longer. That gives you 3 square root of 3 over 3, which is square root of 3. The thing you can check is at 210, everything except for tan and cotan should be negative. Negative, negative, tan is positive, negative, negative, cotan is positive. So if you want me to go through this again on yours, we said all are positive. Over here we said sine is positive and cosecant is positive. All the others were negative. Over here we said tan was positive and cotan was positive. All the others are negative. And over here we said cosine is positive and secant is positive. And all the others are negative. Okay. On this page break, it's just showing a blank page for page 6. Now this one's 3 pi over 4. So your first step is to find it. If here's pi over 4, then 3 pi over 4 is here, reflecting across the y-axis. And so we have 3 pi over 4 is negative square root of 2 over 2, positive square root of 2 over 2. So this one is your cosine, this one's your sine. And so your y value is positive, your x value is negative, your tangent would be negative. If it's positive and negative are the same thing, then you just get -1. And then flip it, so this one's negative. And here you want to flip -1 over square root of 2. Or you could say flip negative square root of 2 over 2. And that gives you, we'll multiply, and that gives you -2 over square root of 2, which we then rationalize to be -2 square root of 2 over 2. Cancel your 2's, so you get negative square root of 2. So that's right there. And same thing here, except you want to flip positive. And then you get that. Now this, out of all of them, are going to be your easiest problem. All you have to do is use your calculator and round. Make sure you're in degree mode. I'm going to wait for it to focus. Okay, so we do secant 32. Remember, if you're in degree mode, that's fine. Or if you just want to get in the habit of using the degree symbol. Now, it just simplified it for me, but I forgot to do Control Enter. I want 1.179. So these calculators do have your menu with your 12 boxes. Your 12 boxes. If you had an old-fashioned calculator, you'd have to do 1 over cosine 32. And then, because there's some calculators before this that did not have cosecant, secant, or cotangent. So you'd have to literally type 1 over cosine 32, Control Enter, get the same thing. But again, it matters whether you're in degree or radian. We want degrees. Now for this one, same idea, but you have to be in radians. How I think of that is it has pi. That's the easiest way to remember it. And so this one has the degree symbol. So that's why in like one of the first videos I said sometimes people just leave it in radian mode. And then you're doing cotan 9 pi over 20 as a decimal. That's 0.158. Again, if you were doing the old-fashioned calculator, it'd be 1 over 10, 9 pi over 20. But just for learning again, 32 is a random degree. It wouldn't show up on the unit circle, which is why if they ever ask about 32, it'd be from the calculator, and so it'd be rounded. And same thing with 9 pi over 20, rounded 2 places. Okay, now on this one, they're telling you the ordered pair, and what we do for this is draw it to the origin. Your -6 means left 6, and your 8 means up 8. Now, in most cases, you're going to get a common Pythagorean triple, like 3, 4, 5, 6, 8, 10, 5, 12, 13, etc. If you don't know that, then you can do your Pythagorean theorem, and you can say -6 squared plus 8 squared equal r squared. Now, since these are big numbers, this is not going to be 1. The triangle wouldn't even exist if it were 1, because, well, it just wouldn't. You can't have a hypotenuse that's smaller than either of the sides. So then you'd say this is 36, this is 64, I get 100. Square root of 100 is 10. So then I'm putting a 10 here. Now, what I would do personally is I would go ahead and simplify it. If all of those are divisible by 2, make that -3, I'd make this 4, I'd make that 5. So I just divided everything by 2. And then it's a little bit easier. This is your x, which is used for your cosine, except for it's -x over r. This is your y. So for sine, it's y over r. Before we just used y, but our r was 1. So this is your angle touching the origin. It's the opposite over the hypotenuse. And the cosine is the adjacent over the hypotenuse, x over r. So in other words, it's the angle next to, including the origin, and then this is your hypotenuse. So you're doing -3 over 5. For tangent, before we said y over x, which is true, we can also say it's opposite over adjacent. Now, if you were in a different quadrant, your signs would be different, but your angle would always touch the origin. On this one, here's an example. They went from tan to cotan. So just do 1 over tan. So -4/3 there, well, -3/4 here. And then this one is 1 over cosine. So flip your cosine answer. And on this one, flip your sine answer. So there really are sometimes where it goes tan to cotan. Remember earlier I said after cotan could be cosecant, but over here after tan is cotan. So just be careful about what you're doing. Okay. Now this one is a random ordered pair. On the circle, it's not a unit circle, and what we have is negative 4, 6. So first, where are you? Negative 4 is left, 6 is up. So you're right there. Negative 4 left and 6 up. Now this one is not a common one. So we're going to say negative 4 squared plus 6 squared equal r squared, which means 16 and 36. That's 52. The square root of 52. Now, since it's even, let's try dividing by 4. We get 13. So that makes it 2 square root of 13. Now I'm doing that a little bit too fast. Remember what I said in another class was if you do 52 divide by x, what you can do is get your homemade table. 52 divide by x. Here's your table, and you want to find your square root multiple of it. What I mean is, like, try dividing by 4, divide by 9, divide by 16. At 4 it really was 13. At 9 it wouldn't work. It's some random decimal. If you go back to 13, it's now 4. So that means it'd be square root of 4 times square root of 13, which we really just simplified to 2 square root of 13. So that's your first step. Now again, your origin touches, that's your angle, and you want your opposite over your hypotenuse. So you want your 6 divided by 2 square root of 13. So that's 3 over square root of 13, and then they rationalize it to that. Because you do your square root of 13 over square root of 13 and turn into that. For your cosine, we're doing the adjacent over the hypotenuse. The other one was the opposite. So whenever we do sine or cosine, it has to do with the hypotenuse. So here the adjacent would be negative 4, and the hypotenuse would be 2 square root of 13. We divide that, and then multiply by square root of 13 over square root of 13. So that's how we get negative 2 square root of 13 over 13. Now for tan, we're doing opposite over adjacent. And so that's your 6 over negative 4, which is negative 3/2. I know it's going to take some practice and getting used to. You might want to do lots of similar questions. Trig is, like, at least the start of it is the hardest part of pre-cal, because you didn't do too much of it in geometry and probably not any in Algebra 2, because it's not part of the curriculum. It's not part of the book. So this might be the first time you see this, but there are whole college classes just on trig. It's after college algebra. College algebra is like Algebra 2. Okay, so on this one, going back, cosecant is 1 over sine. So if we think, what did we have originally? We had 3 over square root of 13, and then you flip it, and then there you are. So that's why sometimes I like to write out this step with this, and then I use this part to flip. And then on this one, it's like 1 over cosine, And so you take your -2 over square root of 13 and flip it. And when I say flip, I don't mean flip the sign. I just mean do the reciprocal. In other words, make it 1 over that, which turns into square root of 13 over 2 with negative. Usually when we say flip, we just mean flip the top and the bottom. But technically, it's like that. And then this one's like 1 over 10. And so you flip -3/2. And so it turns into -2/3. You're going to want to take a lot of notes on these. And then this one, find the exact value if it's 225 degrees. Well, 225 is on your unit circle, and it relates to negative square root of 2 over 2 for both of these. Now, when we do 225 divide by 5, since it says theta over 5, theta is your 225. Theta over 5 would be 225 over 5, which gives me 45 degrees. And at 45 degrees, your ordered pair is positive square root of 2 over 2 for both. And so it's square root of 2 over 2. So it like matches up to right there. Okay, then our last one. On paper, the directions look pretty weird about clicking a button and selecting pi6 and all that. But the main thing is this part. Determine the interval when x is negative. This is plus plus. This is minus plus. This is minus minus. This is plus minus. And so we go 0, pi halves, pi, 3 pi halves, 2 pi. If we want when x is negative, we have to be over here. So that's from pi halves to 3 pi halves. Okay, that would be all for 6.2. Hope that helps. Have a good day.